Welcome to Homework Lib.
We're going to consider the transition from n equal 3 to n equals 7, and we want to know what is the corresponding wavelength for this transition in nanometers. For context, here we're dealing with an hydrogen-like atom or with an hydrogen atom, and for this purpose, let's consider that zeta is going to be equal to 1. So for hydrogen-like atoms, we can apply directly the Rydberg formula, which tells us that 1 over lambda is going to be equal to r times zeta squared, multiplied by the factor 1 over n1 squared minus 1 over n2 squared, where the values for n1 and n2 correspond to, respectively, to the lowest or the lower energy level, and n2 corresponds to the higher one. This is just to ensure that the result is going to be positive as well, regardless if you're employing the emission or the absorption spectrum for the hydrogen atom. Also, the value for the Rydberg constant is going to be equal to 1.0973 times 10 to the 7 meters to the minus 1. So, in our case, the value for lambda would be directly equal to taking the inverse of these values. So let's write it down as r zeta squared times the same formula, minus 1 over n2 squared, and all of this to the minus 1. So lambda would be equal to 1.0973 times 10 to the 7 meters to the minus 1, multiplied by 1 squared, because we're dealing with hydrogen atom, 1 over the one with the lowest energy level, that would be the lowest quantum number, in this case 3 squared minus 1 over 7 squared, and all of this to the minus 1. After doing this operation, what we're going to get is 1.00474 times 10 to the minus 6 meters, which is the same as 1004.74 nanometers, which is going to be our final answer for lambda.